Now we will move on to the next session, which talks about generating code for curve fitting. So previously I explained you how to fit a curve using the curve fitting toolbox, but what happens here is whenever I have a data, I have to go to the curve fitting toolbox, select my x, select my y, and then I have to do all these things whatever I do each and every time. So instead, if we have a code and if we want to do some set of follow some steps in fitting, we can save all of them and then you just use the code to give if you input your x and y values and if you use the code, it will automatically generate the fit. So that is very convenient when you have to fit models for multiple sets of data, maybe identical fits will be very easy. So we will see how to generate code for curve fitting. So once you do this, right, so far what we have done is we have generated x, y, we have called x and y and we have created two fits, untitled fit 1 and fit 3, and we have used a 1 degree polynomial. So we have done all these things, right. So whatever you have done so far, it will be saved in the memory, and when you save file, generate code. So this option is available here. When you say file, generate code, the code for whatever you have done so far will be generated. So you can see it is a function, it is generated as a function, which means that you can call this function whenever you want to do something. So if I have to fit, you know, like if it is this curve fitting is part of some big operation, I save the codes related to curve fitting separately. So that is what we call it as a function. I save the codes related to curve fitting separately, and in that big part, if I want to call curve fitting, I just say create fit and then I give the input values, it will do whatever is defined in this code, right. We will see about it. So it is generated as a function. So this name here is the name of the function and it has two variables x and y, right. So this is what is required to curve fit for any other set of data, and we will see what is listed here. So see whatever is commented here, something like this percentage, it is just for you to understand, and Matlab will not consider that for execution. So that is what is given as a percentage symbol here. So if you want to understand, remember something, you can just use this percentage symbol and that will just remain there, it is for your reference. So if you have done some 10 steps, you want to say in this step I am doing this, in this step I am doing this, you give percentage and you just write some comments. It is just a commented line, it will not be considered for execution. So we will see. So first we have to save this fit because it is a function file. So to call that function you have to save it first. So without saving this, if you just write create fits x and y, it will actually show you an error, right. So you have to save that first. So you go to save, click save as, and then you just save this, right. So once you save this, it is saved in this folder, create fits is saved here. So now I give create fits of x and y, right. So once in the command window I type create fits x and y, my x and y is already available here. So once I give create fits of x and y, so you have to give the function name and the two inputs. So is that x and y are required here, right, the two variables. So you have to give values for these two variables. So once you give x and y, the fit is generated here. So whatever we have done previously, you can see the same thing is available here. But you have to note something, we are seeing two figures here, one for untitled fit 1 and another one with the name untitled fit 3. This is because previously when we saved the session, we saved it for two different fits, because in the lower tab you would have seen that there were two fits which we have done and it has actually saved whatever was there in its memory. So when you generate the code, you should remember that whatever you have done in that session, right, from opening that curve fitting app, whatever you have done, everything will be in the memory. So once you finalize your procedure, you just go do the exact procedure, then if you generate code, it will be convenient. So I have just shown this here to illustrate that particular aspect. So now we have two different fits here. So I do not want two fits, so I will go to the code, right, and then I will delete one fit from this, right. So, you can see it is for untitled fit 1 and fit 3 both are considered here. So, I will go delete the fitting options which are available for one of these fits, right. So, then what we so that is deleted here, and you can see what are the other aspects of the code. We will come to that. I will show you what are the other things. So, here I have just kept untitled fit 1 and I have deleted untitled fit 3. So, we have only one fit now, and now if you use this to fit it, we will be getting only one window here, right. So, next what we are going to do here is we are going to see how to use this to fit for some other data. So, we already have two variables x and y. Now, I am going to give some other variable, and this variable I have defined it as a and b. So, you can see I have given a as 6, 7, 8, 9 and 10 and b as 1, 2, 3, 4 and 5, some other data, right. So, you can have any other data for this. So, for this some other data I want to use this function, I want to do the same fit for this particular data. So, what I do here is I do not have to go to the curve fitting toolbox, click all those things and do it. I just do create fits a and b, because it is not x and y is not fixed, whatever is the name of your variable you can change it here. The function name will remain the same. So, when I give create fits it will remain the same, but I can change my variable. So, I can have a, b, any name which is given here. I can also have it as say for example r temp comma something like this. Also I can define two variables, any name I can give as long as these variables are previously defined. So, you should have defined what this a and b are, and they should be available in your workspace. Only then you will be able to use in your create fits function. If they are not previously defined, then you will not be able to use them here. And again you should see why I have given an underscore here. Matlab will not consider spaces between words, right. So, for that whenever you define a variable, if you want to give multiple names you can give, but then you use an underscore and this entire thing will be considered as one variable by Matlab. So, this is how you use the function to fit any other data that you have. And you can see that we have now got a fit using for a and b. You can see that x is now 6, 7, 8, 9, 10, because I have defined a as 6, 7, 8, 9 and 10, and I have specified a in terms of x. So, I had create fits x comma y is how the function is defined. I have used a comma b. So, x will be a and y will be b for the fit. If I want it the other way, then I should be doing it as create fits b comma a, then I will get the b values on the x axis and a values on the y axis. So, Matlab does not consider anything automatically, it depends upon how we consider it, right. So, this is how we use the function to generate some other fit. Now, let us look into the code. As I mentioned earlier, I am not going to teach you how to write a code. So, this is just understanding the structure of this code and using it to modify some subtle aspects. So, the first one is the initialization of the code. So, it says it is fit result, and then this is how it is defined, because we saw lot of parameters which were listed as tables here. So, it has to generate all these things, and so it is specifying all these parameters. So, which means that in your fit result it has to have all these parameters. So, if you do not want adjusted R square, you just remove this part, okay, like that you can do. So, this much is enough in the initialization part of the code. Next we will move on to the actual fitting part. You can see this ft is defined as the fit type poly 1. Poly 1 is the acronym which Matlab uses to fit a 1 degree polynomial. So, if you go to the help which is available in Matlab, you can see that it is very user friendly. In fact, you can search for the options which are available in Matlab, and then you can try to create lot of fits, modify a lot of options which is used here. So, this poly 1 is an 1 degree polynomial. If you want some other standard form of it, then you can go and refer its acronym, and the options are, the method is linear least squares regression. Okay, use this method to estimate the best fit parameters, and the options are, you normalize and you can give weights. So, we will not worry about that now. Since it is an auto generated code, you have all these things. You can also write your own code wherein you can just finish it in 2 lines, right. And it has fit, the fit result is defined like this. You have the fit for which x data, y data, the fit and the options will be generated. So, this is the structure of the code, and then you can see the next one is the, so here we have given the data, defined the type of fit, then we have actually done the fitting part. This is inputs for fit type, this is the actual fitting part, and this is plotting. Okay. So, in this case you can see you create a figure, name, and the name is given as untitled fit 1, because that is how we have defined it earlier. In the previous case, when we use the curve fitting toolbox, if we give some other name, that name will be reflected here. Then you use H, plot it. So, we have fit result for x data and y data, and then these are all the things which is given in the legend. You say that legend has y versus x with x, and then the name untitled fit. The location, if you see the figure, you will see if the figure is here, the legend was here, right. So, the location is north east. So, that is also specified, and label axis by default it is given as x and y only, and we have this grid, right, these boxes which are available in the background. So, that is called as grids, and the grid is on here. So, we will be able to see the grid. So, these are the some basic terminologies which are used in this code. Now, how do we prepare a script? So, you know that there is a function which is available. You can do some specific step or methodology in your curve fitting toolbox. You can generate code for that, use it as a function, use it for fitting new data. Now, I do not want to do this because my curve fitting will not be one step. I will have data from somewhere else. I will do lot of processing on that data, and at one point I will fit this fit the model to the data. So, my curve fitting is only a part of it, right. So, in that case I do not want to write this every time, or I do not want to write all the steps involved here every time. So, what I do here is I prepare a script, and then I just run it, it will do all the steps which are listed there. So, how to prepare a script? So, previously what we had done, if you have to create fits, you define x is all these things, right, and then y is all these things in the command window, and then you have to write create fits x comma y, then it will do it. But this command window, it will not be saved, right, it is just running in time. So, what I do here is I create an editor, I give all these steps here, and then I will be able to save it. So, I do not have to define my variables every time, and I do not have to write all these times every time I want to fit for a data. So, how to create a script? So, you go to new, you give us a new script, then you will get your editor here. So, then you have your editor, you can write all your commands here. So, this editor I am saving it as fit data. So, this particular file I am saving it in the name of fit data. Already you can see the creates fits function is saved as createfits.m as a Matlab file, right. You will be able to open this only using a Matlab tool. So, I just click save, and then this is now saved. Now, I move on to creating my script, right. The first one I write is CLC. So, this CLC will clear whatever is there in your command window, right. So, this is only optional, you can give or you can ignore this also, but generally it is a good practice to clear your workspace and command window before you start your particular code, right. So, you can always give CLC as the first step. Next one is the clear. So, when you give this clear option, it clears all the variables in your workspace. Maybe previously I was trying to do something, I did lot of random things. So, I had lot of variables generated in my workspace. Now, I want to start something new, I want to clear off all these variables. Then you type clear here. So, you can see I have typed clear in my command window. So, I have previously have all these variables here. Once I type clear in my command window, you can see that all these variables are gone. So, we write this clear here in our script, so that it will clear the workspace every time you start doing something, right. So, we have this CLC and clear here, right. Now, we have to first import our data. Only after we import the data, and we will tell Matlab what to do with the data, right. So, mostly we will not be having data which you can write something like this, right. So, it is possible for an illustration, but when you have experimental data which is voluminous, then it will not be possible to write it manually. So, you need Matlab to read the data and then extract whatever you want from the data, so that you can use it for subsequent analysis. So, I will show you an illustration how to import data from Excel, because Excel is the these days most of the equipments generate data in the form of Excel, because using Matlab or otherwise it is easy to process, but sometimes we get it as CSV files, something like .csv or .dat, all these extensions are also possible, and Matlab can read all these data types, right. So, for this course we will just contain to importing data from Excel. So, I have shown you a data for bitumen wherein an amplitude sweep is performed. So, what is this amplitude sweep? We have this strain amplitude, measure the modulus. We see how the modulus varies with strain amplitude. So, what is expected is maybe it will remain something like this in the linear regime, and then it will start dropping off. This is what you had seen earlier also when you were discussing some basics related to binder rheology. So, this portion where the modulus begins to show a dependency with your strain amplitude, this is called as the linear limit, right. So, now we know that the variation of modulus with amplitude is almost linear for other regions. So, I am taking this particular data, I am trying to use the same fit what we had defined earlier using the function create fits. So, this is all information regarding your data. Again, when we conduct an experiment, the data when it is generated will contain all necessary basic information regarding the equipment and the test what we are conducting here. So, this is a result from a dynamic shear rheometer. You can see the name of the sample, right, and what is the sample, operator, remarks, the number of intervals, the application, the device for which you are using, measuring time, measuring system, accessories, and your constants which are used here, the data collection interval. So, everything is listed previously, right. We do not want all this data when we are doing the analysis, we just want the numbers, right. So, now we see that a lot of variables are here. We have measuring points, again you can specify what are all the variables you want from your dynamic shear rheometer. It will collect a number of variables, but you can choose what you want to tabulate and then export after you have finished your experiments. So, the first one is measuring points, the time, frequency, strain amplitude, your storage modulus, loss modulus, complex modulus, damping factor, phase angle, complex viscosity, shear stress, shear rate, deflection angle, torque, normal force, status and temperature. So, these are some of the variables that you will get as output from your DSR, and what we are interested here is just to generate a plot between your modulus, right, and your strain amplitude. right. So, I do not want any other variable from this, I am interested only in the strain amplitude and the modulus which is shown here. So, if you see, these are my interest, I do not want any other data. Now, I want to extract only this data, my strain variable is strain amplitude is x and my modulus is y. So, I want only this x and y and I want to fit it using the function. So, what do you do here is we write a code, right. This data is a variable, this data can be anything x, y, p, q, whatever it is. So, this is a variable, right. So, this data is equal to XLS read. To read an Excel file, we have to specify it as XLS read. You provide the file name exactly within a single quote. This is very, very important. You have to specify the name of the file with extension. So, it is AS unaged 1 mm. You can see the previous slide. See, it is AS underscore unaged underscore 1 mm, right. So, the same name I have to give with an extension XLSX and the sheet number. Previously, when you see, we were analyzing the sheet in sheet 3, right. So, you can either give sheet number, so that is 3. So, the first sheet is 1, the second is 2, third is 3, that is how Matlab takes. But if you want to specify the name, you can also give it as sheet 3 within quotes like this, after in place of this 3 you can also write it this way, right. So, that Matlab will open a sheet with the name sheet 3 or else it will automatically open the third sheet, whatever be it, right, it will automatically open that. So, that you have to specify correctly. So, then we specify what are the x and y values. So, the x is data from 32nd point till the end and y is data 32nd point till the end, and this is 4th column and this is 7th column. You can see this is how your data is defined here, right. All the information, right, previously I was telling you it had the name, operator and other information regarding the equipment and the tests, all that is not a number. So, when we define an array, it will only take the numerical values. So, whatever is not a number, it says as NaN, right. We do not want all these things, we only want whatever is the experimental data with numbers. So, you can see whatever was given here, right, this information is only shown as NaN here. So, we want to ignore all these things and you can see the data starts from 27th data point, right. So, this is where your experimental data starts. So, I want whatever is the data that is present here from my 27th row. So, then what I will do here is I will write, so this name of the variable is data, right, x is data of 27 till end. So, it starts this 2 is your row numbers. So, I can give from 1 to 5 or whatever is it. So, all these are NaN. So, we are going to ignore it, we are going to start only from 27 till the end, how many ever data points are there, because you might have some 1000 data points or 1230 data points. You do not have to go count every time how many data points are available, you can just give end, it will take till the end, right. If I want only from my 32nd data point for whatsoever reason, maybe my initial 5 points are some trial points, I do not want to ignore, I want to ignore them, I will give it as from 32 to end, right. So, you can choose comma, this is the row, right. So, we have defined the row and the second one is column. So, when you see the previous case, you saw that strain is defined in the 4th column, yeah. See, first, second, third and fourth. So, strain is in the 4th column, complex modulus is 7, right. So, x is in the 4th column, y is in the 7th column. So, that I need to specify. So, here x is in the 4th column, right. So, similarly, I give y is equal to data of 27 till end comma 7, right. So, once I give this, it will automatically extract your x and y alone. So, this is like I have already given, y is 32 to end and this is x is 4th one and y is the 7th column. So, that is already defined here, and you can see it is extracted here also, x and y are generated here. So, you can see x, the values are given here, and for y you will see the values are given here, right. So, we have now from the total data extracted our x and y, then we can proceed with fitting. So, this extraction, right, to select x and y, if you have some 10 experimental data, then you have to do it individually for every set of data. So, when you prepare the script, you just give all these things, you just keep changing the sheet numbers or your file name, it will automatically do all the subsequent actions, right. So, that is the advantage of using a script. So, then we just give create fits x and y, that is all, because see there are only 4 steps. It is to clear the command history, this is to clear all the variables, we are now reading the data. So, calling the XLS file and then reading the file named so and so and taking the data from sheet 3. So, this is calling the data. Then from the total data, so this is your total data will be displayed here. From the total data you have to extract the necessary data. That is what we have done here, and then we are trying to fit, right. So, in this create fits function, whatever was there, everything will be carried out when you call this function create fits, right. So, this is the actual fitting part. So, once you give this, you will see that it automatically fits a 1 degree polynomial for your x and y data, right. So, this is the blue one is my actual data and the red one is the fit, and it is named the fit, like how we have defined it in the function file. So, if you want to change the name, you can go change it here, or every time when you fit also you will be able to change the name. I am not getting into all those details. Similarly, when you read data from Excel, there are also a lot of other options wherein you can just ignore all these NANs and only read what is the numeric data. So, again for that you need to write some 3 or 4 lines, and to explain that I need to explain lot of other parameters also. So, that is why I have not explained that also. Whatever I have shown here may not be the optimistic way, but it is a simplistic way of doing this. Then the final step is how to edit your figures. So, we have defined the plot in the function file, right. So, you can go to the function file and change some things, so that every time when the plot is generated, all these changes will be incorporated. So, we will see here the first one is how to change your x label, because previously every fit which was generated here, right. So, had only x and y. So, we do not know what this x is, what this y is. So, when the fit is generated, you want Matlab to say what is x is and what y is. So, for that we have this option here x label. So, you can see previously it was x and it was y. So, Matlab printed it as x and y. Now, we will go to this and change x as strain in percentage and y as modulus in Pascal. So, whenever you write a text or a string, you have to put it within single quotes. So, in this function, so I am doing this in the create fits function file. So, you go to this create fits function file and then you change x label and y label to whatever name we want. So, here we are giving it as strain and percentage for x label and modulus in Pascal for your y label, and I do not want those grid lines which are there in the background, right. I do not want. So, I want to switch off those grid lines. So, here grid I give it as off, right. So, once I do all these things, my plot is generated. See, the grid lines are gone, the x label and the y label are also changed now. Alternatively, instead of going to code and then changing it, you can also do it in the toolbar edit properties in your figure toolbar. So, when you click this edit in your figure toolbar, you have lot of options. You just click figure properties, right. When you click this, you will get into the property editor. So, you can see that below that the property editor is displayed. You can change line style, you can change line width, the color, alignment, lot of things are here, and when you click more properties you will see a number of properties are now displayed, right. You can see there are lot of parameters which you can change and you can go through it one by one. So, you can modify this plot however you want, and all of it can be done using codes also, but for beginners you can use these options which are here, maybe generate a code and then use that in your function code, so that you will get figures customized in the manner in which you want. So, here also see, instead of changing it in the code, I can also go here when I have this string, right, modulus Pascal, I can also change the name of my variable. So, all these things are possible. So, it has actually a lot of parameters and you can customize it in any manner you want. Similarly, I can switch off this box here, right. Previously we had a box here around the legend, I want to switch off the box. So, you go to box, click this, uncheck this off, and then this box will be gone. There are lot of options, you can go through it if you are interested, but basically we have generated a plot with x and y and we have labeled them. So, I will stop my lecture on this introduction to Matlab here. Dr. Padmarekha will continue few lectures down and she will explain you how to use data collected specifically for bitumen and fit some models, something like a Burgers model for a creep and recovery data. So, she will show you lot of things how to do curve fitting using Matlab. So, in that case all these functions and writing a script, whatever we have discussed so far will come in handy.